Hi everyone, I am SS KIRAN. I am dealing course is electromagnetic waves and transmission lines. Okay, last class I have discussed about electric fields due to continuous charge distributions. Okay, in this class I would like to discuss about Gauss law. Okay, Maxwell's equation, right? Okay. In this class I would like to discuss about Gauss law, definition and derivation. It is also one of the Maxwell's equation. Okay, Gauss law and or Maxwell's equation. Right. Okay. This Gauss law constitutes one of the fundamental laws of electromagnetism. Okay, this Gauss law constitutes one of the fundamental law of electromagnetism. Let us start with this definition. Okay, about this Gauss law. Now, Gauss law states that the total electric flux denoted with psi, total electric flux. While I am writing this law, please try to remember this definition. Total electric flux denoted with psi through any closed surface. Okay, through any closed surface. I will show the diagrammatical representation also. Give me some time. After writing this equation, I will give some diagrammatical representation also. Closed surface is equal to the or same as the is equal to the total charge is equal to the total charge denoted with N. Total charge enclosed by that surface, enclosed by that same surface. Okay, this is the definition of the Gauss law, right? Again, I will tell you, Gauss law states that the total electric flux in any closed surface denoted with psi. There is a field component here, d bar. So any closed surface d bar dot ds is equal to the total charge q enclosed that surface. Okay, right. Now I will start with the definition. After this definition, I will start with the equation part. Now, the total electric flux psi is equal to the total charge enclosed that surface. Okay, based on this expression, I have written this mathematical form. Okay, this ENC means enclosed. You have to write in the suffix of this Q, right? This is the psi electric flux is equal to the total charge enclosed in that surface. Okay, now this psi is equal to the, now I will draw this equation. This psi is equal to the integral electric flux density d bar dot ds. Okay, So this is electric flux density with respect to this surface. Okay, this is the psi, one of the equation derived in electric flux density. Okay, this is about psi equal to integral d bar dot ds. Okay, this is extended to psi equal to double integral. Okay, when if you write this surface or area, you go with the double integral. This is called d bar dot ds. Right now, coming to charge, this is about flux. Now I will discuss about the charge is denoted with q. Okay, this is equal to the integral rho v, total volume charge, rho v dv. Okay, now I will take the boxes or I will write the expression names. This is equation 1. This is equation 2. Is substitute in equation A. You may give any type of name, no issue. Okay, so equation 1 and equation 2 substitute in equation A. Okay, now what happened? Now psi equal to, here I will extend a little bit about this one. This is volume charge density. So this is V means volume. I will go with the triple integral. I will go with the triple integral rho v dv. Right? This is about the charge. Okay, fine. This is about the charge. Right. This is very, very important discussion while solving these expressions. Once again, I will write about this one. This is about the charge. Now, this 1 and 2 expressions is substitute in the equation A. Then I will write double integral d bar dot ds equal to triple integral rho v dv. Okay, now take this expression, we have to apply divergence theorem. Now apply, I will write once again, divergence, apply divergence theorem, to this term. Okay, already we have studied about this divergence theorem. Let us take a bar dot ds. While applying the divergence theorem, we may write triple integral del dot a bar with respect to dv. Okay, this is about the divergence theorem. Again, I will write about this divergence theorem. Del dot a bar dot d. Okay. Now, when I am applying divergence theorem to this term, so this is converted to triple integral. So this double integral d bar dot ds is equal to the triple integral del dot d bar with respect rho. Okay, fine. Sorry, del dot d bar is equal to d. Okay, del dot d bar is equal to rho. Now again, this is expression 3. Substitute in expression B. Okay, now what happened? This d bar dot ds, while applying the divergence theorem, this is converted to del dot d bar with respect to dv. Then as it is, I will write here triple integral rho v dv. Okay. Now equate these two terms. I will write equate these two terms. This triple integral del dot d bar minus rho v with respect to dv. This is term brings to the LHS side. So now this is 0. Okay. Now this term is not, then we may write this equation del dot d bar equal to rho. Okay. Anyway, this is Maxwell's first equation. This is the Maxwell's first equation, that is called del dot d bar, which is the first of 4 Maxwell's equations to be derived.